Hello everyone, welcome back to lecture 10. This is part 2. So in part 1 we discussed about the data type. Now we will discuss about the remote sensing products. So you might have heard that there are many space agencies which are involved in the remote sensing, right? So what is space agency? So a space agency focuses on space exploration, research and development, often with the goal of advancing scientific knowledge, developing space technologies and promoting international cooperation in space activities. So there are many space agencies which are involved in these activities. So what are the major activities? So the first one is launching rockets and spacecraft, then developing and building satellites, conducting space missions to explore planets and other celestial bodies, developing and testing new technologies for space travels, then training astronauts and space scientists, right? Then what is the purpose of this? So when we say the purpose of space exploration or the space programs, so here the first one is explore and understand the universe, develop and deploy space technologies, conduct scientific research in space, promote international collaboration in space exploration, benefit humanity through space related advancement. So what is the purpose? Now you just have to see this particular image, right? So this is the evolution of the earth. So how earth has evolved. Now whether we are going to this phase, whether we are going back to this phase or we are going to some other processes, how our planet will be after hundreds of years or thousands of years or millions of years, that we try to understand, right? So how we will understand this? When we try to understand earth, we also correlate with other planets and then we try to understand the universe. What processes are taking or acting on a particular planet, how things are changing, how earth has reached to this particular time and with all these lives. So whether it is possible in any other planet or not, or whether we are going towards extinction or we are going to have some other processes, and with that we are also trying to look for the potential future human worlds, whether we can find a alternative home, so earth like planet, whether it is possible. So that's why we are spending so much time and energy on the exploration of earth as well as other planets. And for other planets, remote sensing is the only tool by which we can do the space exploration, right? So other planetary exploration, we have remote sensing as a very important tool, right? So when we talk about this space agency, some of the prominent space agencies from around the world are listed here. So the first one is in this list is ISRO, Indian Space Research Organization, India. Then National Aeronautics and Space Administration, that is NASA, USA. Then European Space Agency, ESA, that is from Europe. Japan Aerospace Exploration Agency, JAXA, that is from Japan. Then Russian Federal Space Agency, this is from Russia. And then China National Space Administration, CNSA, that is from China, right? So these some of the prominent space agency, but there are many other space agencies. So this list is not the complete list. This is just for the example so that you will understand what we mean by space agency, what are their role, what is their purpose. So that's why I have made this list. Now here you can see some of the notable space missions. So the Mars mission, which was very famous. So in the news you might have heard about the Mangalyaan, right? So the Mangalyaan is nothing but the Mars Orbiter mission, MOM, or the Mangalyaan. It was very famous. India's first interplanetary mission, orbiting Mars. Then next one was the Perseverance Mars rover. This is NASA's rover exploration and it is for the Jezero crater on Mars. InSight lander, this was again from NASA. So here it was meant to study the interior of the Mars. Then we also explored the lunar missions. So the Chandrayaan 1, 2, 3, there was many missions. So here India's third lunar mission aiming to land a rover on the moon surface, because we wanted to collect some of the in situ information, right. Then Chang mission, China's lunar exploration program, including sample return mission. So sample was also collected. So these are some of the list, it is not again the complete list. This is just to tell you that there are many activities going on and for the space exploration or to understand our own planet, the Earth. Juno mission, this was launched by NASA, ESA and ASI, right. So like that we have many mission focusing with different objective and different aim, right. So with different aim and objective, these missions were launched and we are trying to understand our universe or our own planet to survive on this particular planet or to know what will happen with us in near future or in the future, right. So when we talk about this space activities, the satellites plays a major role, right. So when we talk about the planetary exploration, so here we are sending the satellites and then we are capturing it, right. As I mentioned this in the previous lectures, space-borne satellites are the carrier, right. So remember, satellites are the carrier of the payloads and they carry instruments, equipments or systems designed to perform specific functions or tasks while in orbit, such as communication, observation or navigation, right. So this is satellites and payloads, because they are carrying these instruments. So the scientific or technological instrument carried on board a satellite for a specific purpose is termed as a payload. So these are the payloads which are mounted on this particular satellite and they are doing the measurement. So remember, satellites are the carrier, payloads are basically your sensors or the instrument which actually works, right. So platform is your satellite. Satellite sensors are instrument mounted on satellite orbiting Earth or other planets, capturing data across the various electromagnetic spectrum band about the surface and atmosphere, including image, temperature and other parameters, right. So here you can see some of the satellites which are in this particular figure, and these are capturing the information in different wavelength. So various electromagnetic spectrum bands are used to capture the information, and these informations are about the surface and atmosphere. Here it can be an image, right, it can be only the values. So those both are remote sensing, right. So space-borne satellites, they are carrying the payloads and the payloads are basically the sensor. So these sensors, this is one of the example and it is from the Earth Resource Technology satellite which was launched on 23rd of July 1972, and later on in 1975 or so it was named as Landsat satellites. Since 1972 these Landsat satellites are continuing. So we have various series, Landsat 1, 2, 3, 4, 5, 6, 7, 8, 9 and the latest was launched in 2021. That's why we call it the longest continuous global record of the Earth's surface. and this is one of the data which is available in the public domain. So, if you are familiar with remote sensing data products, you might have heard or you might have used the Landsat data, right. And here this particular graph tell you the different band combinations which are available for this Landsat data sets, right. Some of the examples of spaceborne satellite data. So, here you have Sentinel, MODIS, ALOS Pulsar, Aster, Hyperion, IRS, Cartosat, ResourceSat, Aryabhat, then Iconos. These are available from different space agency. This is not the list of a particular space agency, it is the mixture. So, these are some of the commonly used satellite data sets which are popular, but this list is not in the complete list. So, some of the key resources I want to highlight here. If you are willing to work in this particular area, you can get the data from USGS Earth Explorer, NASA Earth Data Search, Copernicus Data Space Ecosystem, Sentinel Hub, Bhuvan ISRO, NOVA, Google Earth Engine, Meteorological and Oceanographic Satellite Data Archive Center of ISRO. So, these are the agencies which are giving you the data sets, but again these list is not the complete list. You may explore more addresses or the web page where you can get more or the various data sets. Then digital elevation model, you have one of the most popular is SRTM, which is Subtle Radar Topography Mission. Then Aster GDM, this is from Advanced Spaceborne Thermal Emission and Reflection Radiometer Global DM, GTOPO 30, AW3D 30, Iconos, Cartosat, these are providing you the digital elevation models, right. Now, we will try to correlate these or use them into the GIS information. Now, we have learned about the data type and the remote sensing products. Now, we will try to use these information together and we will have the GIS environment, right. So, before we continue with the GIS, we should understand what we mean by GIS. So, when we say Geographic Information System, it is a system designed to capture, store, manipulate, analyze, manage and present all types of spatial or geographical data. Now, here all type of spatial or geographic data, that is very, very important. So, what we mean by spatial or geographical. So, the data set which are having the latitude, longitude information, that means the location information. When we are having the latitude, longitude information for a given data set, it becomes spatial or geographic data, right. Now, here again we will refer to this sentence. So, it is a system to design to capture, store, manipulate, means we are capturing, we are storing the information. So, when we are capturing, the whole remote sensing can be here, right. We are storing it, means we are maintaining the database. Then we are playing with that data, we are analyzing. So, the analysis is also within geographic information system. Then we are managing it or we are updating the information, because maybe you have collected some data, because here it is not necessary to have the data from remote sensing, it can be from your field, right. So, once you have collected the data from the field, let us say water table depth, then we are having air quality, then we are having the population, then we are having this map, and all these records are against this particular point, right? So in GIS we are capturing, so we are going to the field, we are doing the measurement and then we are storing it. So we are making this table here and here it will be X, Y, and now the attribute we can generate here. So here this is the first one, this is second one, this is third one. So the first, second, third, everything can be stored here, right? Then other parameters are also listed here, 5, 6, 7. So everything is listed here, so we are storing it. Then we are trying to analyze it, right? And then we are also trying to manage, means let us say this is till 2025. After we did this study, maybe the next group of people, they are also doing the same measurement. So they will update this information. So let's say in 2030 we have some more information. So we are updating the information, right? So this is managing this. And now finally we will be representing the information in terms of map. That is also a key role of geographic information system, right? GIS allows the integration of many data in a single map. Now to understand this, maybe one group of people or one person has developed a map. This is the capital of states, right? Now the second group of people, they have generated the state boundary. So this is the state boundary, right? Now the third group of people, they are generating the surface water map. So this is a fluvial system, right? And here you have one lake, right? Now taking these three groups together, these information together, we can overlay them together and then we can have one map, which is basically the fluvial map. Then we are putting this state boundary here. Please do not mind, I may not match with these boundaries, but this is just for the example, right? Now we are putting this capital of these states here. For each polygon we will have. So now you can have this kind of map generated because the GIS is enabling the integration of data sets. Now once we have this kind of map, we will be easily calculating whether this capital is far from this fluvial system, whether this particular capital is very far from the next capital of the adjacent state, how far it is, right? Then whether this fluvial system or this river is crossing all the states for this particular country or not. So this kind of information is possible to extract only when we are working with GIS, right? Because GIS will be having the spatial or geographic data, and those are having the latitude, longitude information, and that is important to extract the information or even to integrate different data together. Otherwise, it will not match the boundaries. Here it enables the visualization. I explained you, question whether this particular capital is far from the river channel or not, analysis of the data, interpretation of the data, right? So here you will try to understand the relationship, pattern and the trends more efficiently. So that is the advantage when we are dealing with the data sets in geographic information system environment, right? So GIS is an organized collection of computer hardware. You need a computer hardware, you need a software, geographic data and a group of people, that personnel. Here to capture, to store, to update, to manipulate or to analyze or to display the data. Now here it can be a group of people, maybe first group is responsible to capture, second is responsible to store, update is third group, manipulate is fourth, or the analyze and the display is the fifth group. So it is not necessary to have it with one group, it is multiples of people are involved, that is also possible in GIS, right. So let us understand first, when we talk about geographic information system, let us start with the data. So when we collect the data and then we try to store it, right. So whether this is information or whether it is different, right. So I will explain you with one of the basic example. So this is the question. So when we try to answer whether data is the information or information is different, right. So before that we need to answer some of the question. So whether data and information both are same, so they are different. Data is of little use unless it is transformed into information, right. Information is an answer to a query based on raw data. We transform data into information through the use of an information system. So we will try to understand with some of the examples, then I hope you will be very clear about these concepts. When we communicate our information to a computer, we basically put these values, because computers, they understand only the numbers, right. But when we try to see them, because we will not be able to remember all these values, right. But what computer does, it will be converted to some letters, right, and these are very easy to remember, right. So here you see, this is the data, this is the information. So we do not remember this, but we will easily identify or understand this. So this is the information and this is the data. So without information, that data is of no use, right. Now what is information system? So here we will see some example. Now here you have a information system, right. Just assume this is a information system and you are having a question, right. So when you are having a question, you put that query here in the information system and then you are getting the answer, right. So this is called information system. So it is basically the database, right. So the information system is a system which is able to answer your query. Now some of the information systems are phone book, right. When you go to library, you have catalog, or nowadays Google search engine or any other search engines, that is one of the best example. But that will not be the information system. Here we are talking about the information system. That is again the digital information system, where everybody is connected through internet, right, and knowingly and unknowingly we are sharing our data, our location information, or when we are traveling from A to B, we are sharing our velocity, at what velocity we are having the vehicle. When we are trying to reach B from point A, we are sharing our mobile data sets, right. So on that basis it can calculate what is the speed at which you are moving. So those information are used to suggest others how much they will take to reach from A to B, right. So this is one of the example how this digital information system work. So the digital information system is an integration of hardware and software to enable advanced research, communication, education, awareness, etc. So nowadays you might be confused about some topic and then immediately you will search it in the internet, right? You will search and you will get so many answers, and then it is your wisdom which one to select, right? So information whatever is available in internet, that is not correct. So it is not wise to randomly use the information or absorb that particular information. So wisely use which information is correct, and then you have to understand that particular statement. So when we say geographic information system, data acquisition, procurement, that is also part of it. Data management, that is also part of it. Then qualitative and quantitative analysis, that is also part of this GIS system. So this is one example I would like to show you, so that you will understand in which areas or in which domain GIS is used. So here you can see list is not limited to this, right? So application of GIS and remote sensing products has been increased with time. Nowadays most of the people working in the hazard related studies, they are having the remote sensing products, right? So remote sensing and GIS together makes a very powerful tool to be used in hazard studies. So with this I will end this lecture. Thank you very much. We will continue this course. Thank you.